How's it going, everyone? Welcome again. Another video here looking at generators. What in the F is generator, right? Which is this particularly nice little keyword or tool that is provided by JavaScript to give us a behavior that previously it requires a lot of work to do. What is that behavior? What kind of behavior is that, right? Well, that we need to somehow is to have a way to have a pattern to describe an state machines, or to have at least is a syntactic form to describe a state machines. And for those who are not aware of this state machine, this is just a series of flow of steps from one step to another, to another, to another, to another, and then descriptively lists out all the transaction outputs. So this is something interesting and powerful because now if promises, which is something that we saw previously in other videos, is all about if promises are all about to solve the inversion control and callback hell, generators are all about to solve the non-sequential and non-local reason problem. So non-local and non-reason and non-sequential reasonability problem. And we're gonna see how actually that works into this video, and again, and have some more practical approach of how all of these things works. So that's a very interesting thing here. So the whole idea of generators, which is something that comes from another language like Python, and placeholders, the value proposition is, hey, we will need to have some sort of placeholders around to eliminate time as a concerning factors wrapping around a value. Why is this? Because with promise, unlike thongs and callback, which thongs also guarantee is this ability to not worry about time as a complexity, as a containing factor, as a complexity factor of this. Now this factor or now thongs, which the value proposition of that is that let's going to eliminate now is time as a concerning factor by now abstracting that and using closures in JavaScript, right? So the whole point of this is that this thong is, let me give you everything that it needs, okay? And by the time I call this function, I'm just gonna get the value out of this. And with the and with the and with the how do you call it? And with the come back, okay. Jesus, did I lose my mind? So with thongs we have this, right? This is for handling asynchronous scenarios, but for asynchronicity, okay. So thongs, now this particular pattern would say, hey, put everything that this function needs, okay, and by the time that you get that value, pass a callback to get the value out of this. And also we look at how can we implement that now in JavaScript and all that kind of stuff. So that's huge in terms of now we don't have to worry about is the time as a concerning factor, which is when we implement now callbacks, we have to handle all of this by hand. We have to say, hey, we have to wait for all of this response to come, especially if you are, for example, performing some Ajax requests or any of these side effects, okay? Whether it's calling a database or another local storage, perhaps memory, or sending now a request to a server, right? So if you have to handle this kind of operation, so you have to wait for that value to get to be. If you need to wait for that value at some point in the future, well, the point of this is now with this callback approach, we have to handle everything by her. This coordinations is something that we have to take care of, and that is, for example, if you're sending in parallel requests, which is one after the another, the Ajax request. So you need to handle is waiting for those responses to come back, respond as soon as they came in, coordinate it is response, and then show them in the proper order that they were called. So this coordination problem is exactly what we are talking, and this is the topic here that actually we as a JavaScript developers, we need to take a proactive attitude to learn to have the disciplines to understand these particular problems, and what are the strategic and tactics that we need to use to come out with this, to come after or to come out of this particular problem. So this is the block that we are dealing with, all right, and we need to find a way to understand that so we can now cross over that. So that's why we are now looking at generators, right? So because I look at other particular patterns that allows to handle this coordination that I'm talking here, okay, with callbacks and thong, which is especially with callbacks, like now thongs, and then we have now promise, which is something that comes from the programming language E. It was made by one of the TC39 commit members called Mark Miller, where in that language they have something called now futures, okay, and then now in JavaScript we have something similar to that, and this is now a concept that comes from the functional programming, because at the end of the day now promises are monads, and this is very important to understand, perhaps not right now because that's not the goal of today's video, but is to deeply dive deep into the concepts and the problems that we are solving here, especially with asynchronicity. And this promise is now a monad, which is one of the best way to describe in terms of functionality, is that it's a way to model a state change. So right now I don't want to dive deep too much into the hardcore terminology of monads, okay, which is a monoid of end of functors. Again, there's a lot of jargon there. So for today's video and for this series of videos, where we care about is now the asynchronicity. What are the patterns that we can go with, and understand what is the specific problems that each one of them are solving, so we can have now a more understanding. So by the time we need to deal with this recurring issue, if you need to provide this service to any company out there, you know what you have to do. What are the tools that allow you to do this? So that's right. That's right. So yeah, after all, this is promise, right? And how promise now give us is this, not only flow control but also data flow. So unlike now with this particular tool or behavior that the JavaScript developers, or in this case the JavaScript engineers or the TC39 commit actually wants to promote to the language to help us to solve this specific problem in terms of, so far we have solved is the inversion control and the callback hill with promise, where we need to actually make our code synchronously, pretty much like JavaScript is at the end of the day, which is a single thread, which means that functions run, it has this fancy name of functions run to completion, which is no one can preemptively interrupt the execution of these functions with something. And this is something huge. This particular behavior is what gives us now the single thread way of, or give the JavaScript single thread nature, and also the ability to reason about all of these problems and to program, to write this code. This is the way of how our brain actually works. Again, I'm not a neuroscientist. This is just based on the observation that most of the time we plan things in this sequential blocking fashion. So generators is now a way to say, hey, we can now not need to run to completion. So we're going to add this now weird quote unquote behavior, right? So why they want to actually bring this weird behavior, you may wonder. Well, it's not to bring chaos to this, to the language, because of, like, for example, those language that support this preemptive concurrency, all right, which is the ability to now interrupt the function execution with something else. That doesn't mean that in JavaScript we can call a function during the execution, but we can interrupt the execution of a function with something else, right? That is not a function. So again, because now when you're dealing with this multi-threading programming, you need to actually solve problems like resource shares logins or semaphores as a way to preserve the state in a way that is in a consistent and an integral way of doing all of this. And I think that's quite interesting and fascinating, right? Absolutely, absolutely. Why is that? Because as we dive deep into this concept of generators or function that they don't need to run to completion, it means that these functions now will run until the yield statements and then resume that, right? So the idea here is to actually make this particularly, is to bring this behavior of this state machine, this syntactic form of state machine. Again, and the state machine is, for those who are not familiar with, so state machines are this series of, it's a way to have a pattern of series of flows from one state to another, to another, to another, to another, and descriptively lists out all of the transaction out of this. So this interesting concept of state machines, which is when we talk about this syntactic form, I don't want to dive in too much, but this syntactic form is just a way to say, hey, this is the arrangement of words that allows to describe, or this is the arrangement of words in a language that now make is grammatically correct sentence, which means is this set of rules that the language now provides for us, or it has. Now it is made of the syntax, which is the way of how you organize words, the morphology, how you compose these words, the phonetic, how this, how those, how this, how this word sounds like, and the semantics. What is the meaning of this, right? So again, the meaning of this state machines is that we have now this way of having a pattern of series of flows from one state to another, to another, to another, and then descriptively lists out all of the transactions out. Now, you can simulate this behavior with callbacks and iterators, okay? But it requires a lot of works and careful programming to do that. However, if you're not familiar with iterators, which is a way of stepping through typically data sets, okay? So you can think of these generators as the, how do you put it? Yeah, you can think of these generators, right, as a way of, so if you go to YouTube or the VCR, right, when you hit pause, that's freeze in that frame, and then we'll wait until you come back later and then resume. So these generators is you can think of generator as a function that when you, or you can think of these generators as a function that pause when it finds the yield keyword, as a, even in the middle of a statement, okay, and everything is frozen, and it will wait indefinitely until some actor comes here and say, hey, it is time to resume. This particular process of how it's going to wait, for how long it's going to wait, is perhaps quite magical thing, you know. It's interesting, because this ability to pause and resume a function here is something that you can achieve with iterators and closures and callbacks, all right, to actually have this particular pattern of a state machine. Interesting, okay? So you can think of the generator as this function that pause and that pause and resume, pause and resumes. While the generator is paused, everything here is blocked, or everything inside of this is blocked, and it's not blocking the entire program. So this is, so because no one from the outside, interesting, because no one from the outside can interrupt or preemptively interrupt the execution of the function, this is what's called cooperate concurrency rather than preemptively concurrency. So as we can see here in this particular line is, hey, we're defining of generator with this asterisk, okay, and by the time we call this, we're not gonna get this generator stuff. What we're gonna get instead is an iterator. So is this iterator? So if an iterator is a way of stepping through a data set, now here, so you can think of this like a database, when a query, for example, the result of a query database, when you can call the .next function and .next and .next until you get that. Makes a lot of sense. Now the iterator is a pattern for stepping through typically of a set of data, but in this case, we don't want to stepping through the, we don't want, but now we're not going to step through data, rather to the control of the generator, to the flow control of this generator. So we can stop our generators, but we can ask to run until the pause. We can call it to the next resume and so on. So what we can say here is to say, hey, we can is now run this iterator, get into the functor or to the generator function, and when time find a yield, even in the middle of a statement, then it's going to now pause that and get out of the flow of that. So it's gonna pass the control. It's gonna pass the flow control to whatever call him, right? And this is something crucial here for the generator to understand that from the inside perspective, right? And I understand this. It was by the time that I created this typing animation, okay, which was a very fancy animation here, right? Say start, hello world, right? And this is quite interesting how we did this. But it's all about to understand now that generators, it also act as a message passing here. So because by the time we create now a generator, let me see here exactly. So we interesting. There you got it. This is it. It must be here. Okay, so this in fact, so the following code here is just a way to, so the following code is just a way to the following code is just a way to the following code is just a way to wrap into a function the next call from the iterator, which to me was quite interesting. That's very, very interesting how you can create this helper function or these as abstract functions here by creating now a function that wraps whatever it needs data, and then you now return a function that by the time that it's being called is actually calling or applying here is the function that you want to call it, or you want to apply with the context, all right, which is part of the it. Hey, I want you to now this function have this context. Interesting. The context of this data followed by its arguments, right? And that's quite interesting. That's very, very interesting. These arguments object live inside of the function, and in this case inside of this particular function. So if you're passing any arguments to that function that you're calling, it's gonna get those arguments as it is. So this now, by the time we actually is defining a function here, and the TLDR of this function is that the way of how you can describe this is like it is a pause and resume, pause and resume, pause and resumes. Anytime you call the dot next, you are think of this from the inside perspective of the function. So anytime you call that run function, which is anytime you call the dot next function, you get into the functor, to the generator, is asking a question, okay? And then when it resume, when it pause, is asking a question. This is true? Yeah, when it pause, is asking a question. When it's resume, is answering the question. Is this true? Because we are from the side perspective is we're passing this value, okay, or we are calling that. So from the inside perspective, they say, hey, I'm going to evaluate this statement, okay, and then I find yield keyword. I must pause it. So I'm asking a question, or is asking a question. It's like, I need to pause it. Hey, and then I go to return the control, right? And by the time that this is being resumed, it's a okay now where I was, you know, where I was. Oh, it was now this here. I receive a value here, like so, and then next you're gonna actually is evaluate the next statement. Hey, I find a yield keyword. I'm going to stop here and then resume and then pass over the control, okay. And by the time some actor call this function, you say, okay, good. Now you have to handle this. So now you're gonna resume this execution. Say, hey, I'm going to now, I find this yield word. I'm going to now is pass control with this particularly value here. But again, this pause and resume, pause and resume, pause and resume is something that if you can imagine that we can hear now which is a message message passing two-way. It can be quite it can be quite yeah, it can become quite how do you put it? It can become quite it can become quite cumbersome to deal with, to handle that. Especially when we are going to look at when we're talking about message patching in two-way, it's like, hey, these particular generators, when you initially call that, if you pass a value, it will evaporate. It won't accept that. But this is now a flaw in the design of the generators. Okay, but okay, let's go into now answer the question of promise and promise and generator, and this was interesting. Let me actually go to the code pen here, okay, and now describe the thing. Oh my god, typing animation, no, what? But this is not what I want to. Oh, it's because it's heavily zoomed. Okay. So this is it. You got pen, you got view pen, no, a simple pen, right? And here, since we have now this functor or this generator, all right, where we can say, hey, the name of this function is now main, all right, for simplicity. We can easily find some code routine as a way to have a wrapper functions to only that this function will give us now is the next as a way to get into the function to the generator, all right. So we don't have to actually call that iterator.next. Now you see, we simplify our life here by saying is the coroutine, okay. here we get receive is the generator, okay, and then we now store that as the iterator, but we need to run this. So a generator, once you call that, actually get this iterator, which is the iterator again is now a particular object that follow is the iterable and iterator protocol, which is this generator object going to return now an object with the shape of the value and done as a boolean value. So okay, it's going to return is this dot object that contains dot next. That inside of the dot next, when you call it, for example here, iterator protocols like that. For example here, it will have now the next, the done, and the value, right? This is the iterator protocol. This is now how they're going to produce the sequence of data and have inner order and have keep and tracking is, and now have the ability to track this internally for us, right? So we can actually implement our iterator. That's actually quite interesting by using its closure, all right? But again, because that requires a lot of careful programming, so might not be an ideal for that. And that's why we have now generators. So generator, after all, is going to produce this. If you don't actually believe what I'm telling you, we can quickly say, hey, yield 1, and then yield 2, and then yield 3. All right, so yield 3. And let's now going to actually console log this to the main and calling it. All right, so it's going to produce now this, which is an object generator. All right, this is quite interesting, these object generators. If we want to take a look now what this object generator is, we can say is this is interesting. This is a very interesting way of looking at this. Object generator. How to visualize in JavaScript objects like this. You hallucinate, bro. You hallucinate, bro. You hallucinate, bro. Okay, it actually created that visualization for, oh, holy crap. In React, why do you make this in React, bro? It's like, did I ask you for JavaScript? Yeah, you create an interactive thing. It's like, but I don't wanna. You hallucinate a lot. You know, it's chill, bro. Okay, I need to be more specific. That's what happened. I need to be more specific. That's all. Okay, no problem. The console table method is particularly useful for visualizing array and objects in tabular. Oh, let me see if the cloud actually reached to that conclusion. And you hallucinate, bro. Use console dir to show all properties. Console dir. No. Console dir, console table. Nope. All of you are hallucinated. But console dir. Console dir. Well, it seems that this is not working. It seems that in here this is not working. No problem. No problem. No problem. Okay. Chill, chill, chill. There you got it. It's now showing this. Okay. Okay, show dir. Okay. This is show dir. Right? Exactly, show dir. And then you got also show table. Alright. Difference between show dir. Oh, interesting. Show dir and show table. All right. Oh. So for example, if I did this. Oh, that's pornographic. That's pornographic. That's pornographic. Oh, the index. Oh, Jesus, French those guys, bro. Okay, but it required a lot. It required to render. Okay, powerful render. Exactly 1,000 file lines. Oh, right. That's powerful. That's lovely. Console API. Clear count there. Error grouping, for log time. Okay. That's quite interesting. Alright. Time, console time, and time end. Okay. Interesting. Okay. Anyway. That's quite interesting. So if I want to take a look at that, so you can see here now, this actually showing is this. So this is now a function that has it's a special type of functions, the generators, that has its function constructor, all right? And also it is properties that inside of the prototype, it has now this reference that actually points to that. So it is prototype, where now the prototype is uh, the place where you put all of this additional property that this function might have, and inside of that it will have now a reference to the base class. This is known as the prototype change. As you can see here now, it say, hey, this generator function, okay, which is a special type of functions, and functions are a special type of objects, but this is now a function, an iterator function, right? That this iterator function has the object here with the next, return, and throw, as well as the object properties or the iterator properties. Interesting. So for example, drop, every, filter, find, this common transformation methods that we can go with. And not only that, this iterator prototype or this iterator object must have a reference to the object as well, to the object iterator prototype here. That have now the reference to the object. But look at this through the prototype change. It's now under the prototype that it has this reference, which is private reference of the proto, that now have a reference to other object that it needs to access. So that's a way to reuse is this data and functionality, but as a way to reuse its functionality here. So in any case, so this is now an iterator function, okay? And this iterator function is made of that. You have the next, return, and throw. And inside of the next, you have now, since this is now a function, that return is yes, this is now a function that return is the following values. In this case is this is the constructor here, constructor object, but it say the next, right? That is going to return is okay, but this okay. To a string, this is the method that you can have access to. A bind and call and caller and function. So by the time you call this function, now here we're looking is at the prototype reference, exactly. So in any case, this next function actually what it's doing is what? Oh, okay. This is interesting, but no, it's preferred to use there. Okay. But in any case, exactly. Well, again, this is the console from there. But in any case, this actually return is that object that we saw, right? It's an object generator that contains next, results, and error, where inside of this you have now this shape that you can have access to this, right? So here, because now we're getting is this object generators that contains the context for that, we're going to now return as a function to create effectively a closure here. And again, after all, functions are function by itself has the value of this, which is contextual, is not lexical, and the arguments property. So we can now return and say, hey, the .next by .next apply. Okay, I want to pass now the context that this function will need when I call this, in this case the iterator object, followed by the arguments here. So all of this is just as a way to now wrap this and then trigger the first function here. So what we're gonna do here is just to do this with the main. Say, hey, we actually create this generator function. We want is to pass this and as a argument to the routine, right? Like this. So this is now coroutine. And because this coroutine, what it's going to return is now the next function being called, we can call this step, right? And do this, right? We can call this a step. So by the time we call it step and we say, hey, console log step, right? And we run it, right? Because it's plural, arguments, exactly. Now what we're getting is this particular object that is returned anytime we call the next, which is, hey, resume and pause, right? It's like, hey, go in there, evaluate that, pause, and by the time we call that again, we're gonna get is the second evaluation, right? Which is here. And this is something that is quite trivial in terms of generating sequences of data. Now, this way of modeling is a state machine, which is a great thing. But there is also something that is quite more interesting here. Okay. Something that is way much more quite interesting here. That is what will because at the end of the day, what it's doing here is that anytime we call the run function, we're getting to that, the generator evaluate that expression and then say, hey, I found a yield. Now initially, if you pass any value, it will disappear, that it won't take that in consideration. This is part of a flawed design. But it's going to evaluate that statement, and by the time you find a yield, it say, I'm gonna pause here and pass control. Here is what it is. I'm gonna stop here, okay? I'm gonna freeze here, I'm gonna pause here and freeze everything, block everything inside of this function, okay? And then pass control. And this is something important, because this understanding, a way to describe this, is the reason why we have now this particular concept so powerful in our asynchronous programming. And take a look at this, because now with this coroutine function that we define here, okay, if you can imagine now a functor or a generator with the following here, you say, hey, I want to now declare this as run. Okay, so routine. Okay, where now this generator is gonna call is what, fetch, nothing for now. Where here now this function, what it's gonna do is say, hey, let me now is call here or stop the execution, but I'm going to now pass the control to a function called getData, right, with this value. That's what it's gonna do. It's like, hey, I'm gonna pass the control to this data, get value, all right, and this function here, get data, that will receive that as the value, right? We can say, hey, by the time that this generator pass control to this function here called get data, we can say, hey, we can mimic set timeout here is the this behavior of this asynchronous operation by saying, hey, let's go to actually now is instead of console log, let's go to now actually is resum the function execution here, right? So let's go to resum the function execution here by saying, hey, let me now call run here with this value. All right, and then you say, hey, by the time we resume, or by the time we get into the function, we want is to now store that value in something called X, right? And then at some point in the future, I want you to now yield, all right, X value, just like that. So by the time we now initially run this function, okay, we say, hey, let's go to run this, okay. So after a second, let me actually is now console log this because we are not, okay. By the time we call this run here, so by the time we call run, it say, hey, let me now evaluate here and say, hey, I find this, so let me now pass control to this thing called get data 30. It's going to receive that, and at some point, right, it's going to now call, okay, and at some point it's gonna call that run with this value. So these functions are hosted. Oh, it's because these functions are not hosted, so you need to host this. This is interesting. Or we can say it's just like this. Say it return this. So let me actually remove all of this for that. because what we really care about is this one. So by the time we call this run, it's gonna say, hey, let me now pause the execution of this. All right. Let me pause the execution of this, unless I have to say something like this. Let me evaluate this expression here.
Just going to
the question is this
configure the way all of this stuff is happening. From the inside,
work?
it's going to look exactly the same. But what we can observe here, which is actually it's kind of good that some of these questions were being asked from the chat, because what we can observe here is we're still every bit as susceptible to callback hell as we always were, aren't we? At least one of the things of callback hell. We have an inversion of control issue, don't we? Somebody can call it.next in a way that we're not expecting and screw everything up. We still have an inversion of control issue. We've solved the non-local, non-sequential reasonability issue, but we have no solution currently in this code base for the inversion of control callback hell issue. So guess what we're going to do? We're going to put promises together with generators. Promises are going to solve our inversion of control issue, solve our trust issue, solve our flow control issue. Generators are going to solve our...
This is not working. Set timeout. Okay. Set timeout, right? Set timeout. I want you to now is do this, right? And call and run this function. Yeah, you can call this function only. Exactly. Call this function. There is something interesting here. So by the time you call run, if you do this, you don't have access to the value of this and all of that kind of stuff. But if you do this function here, we still get this funny object here, undefined value. Oh, because we need to do that dot value. But it says undefined. And down is false. So I want you to yield this, all right, which means that call this get data, pass control to that.
Oh, issue. So guess what we're going to do? We're going to put promises together with generators.
This is interesting. This yield get data that is supposed to not only call that, so pass control to that.
Promises are going to solve our...
Okay. So we have now this yield stuff here. Okay. Exactly, an expression. The value to a yield from the generator function is evaluating an expression, or it can be in the middle of expression. If omitted is undefined, is yield. Return the value is this optional value passed to the next generator. Exactly. That value becomes the value returned by the generator current yield operation. The first next call does not have corresponding suspend yield operation, so there is no way to get the argument passed to the first next call. Okay, so by the time I run this, right, it's gonna stop this, and there is no way to actually pass that in the first place.
Version of control issue. And the key recognition for this, instead of yielding an undefined value, we're going to wire this up so that we are going to yield a promise. Now I want you to think about this conceptually before I show you any code. Look at me. Inside of my code, when I say yield and I make an AJAX call, if that AJAX call returns me a promise for it, am I yielding out its promise? Yes. So who's going to get the promise that I just yielded out? Turns me a promise for it. Am I yielding out its promise? Yes. So who's going to get the promise that I just yielded out?
Who's going to get the promise?
Am I yielding out its promise? Yes. So who's going to get the promise that I just yielded out?
The promise.
Whoever's driving my generator with its it.next call, right? So imagine there's some plumbing somewhere, which is going to be in a framework or a library, but there's some plumbing somewhere that says it.next, and what it gets back is a promise.
Mm-hmm.
So what's it going to do with that promise? It's going to say promise.then it.next.
Mm-hmm.
So here's how this works. We yield out a promise, pausing, and then we say .then, and when the promise resumes, when the promise resolves,
exactly,
we resume the generator. And then we yield and pause, and then and resume, and yield and pause, and then resume.
The yield, the pause, and then the result.
That's how we make that magic work. That's how we wire promises into the generator. We yield out promises, and then the promises resume the generator. And when the promise has some value to pass along, it passes it along to the it.next call. So that plumbing, that circular plumbing that I'm talking about, you could write a utility to do that for your generators. It's about 25, 30 lines of code to handle all the little nuances and error handling and all that other stuff. You could do it. It's in my book. You can see the snippet right there if you want to write your own. But you shouldn't have to. I want you to understand the concept of what it's doing. It's yielding out a promise and resuming a generator and yielding out a promise. I want you to understand that concept. But it's not practical for each of you to go invent your own driver for these generators. So you're going to need one that's built into a library, and it turns out Async has one, Q has one, Co has one.
So, but this is interesting. This actually is not working. Not working as expected. Because by the first time I'm yielding this, all right? So plus 1. And the second time I yield this with 10, and 30 with G, then you're gonna yield is and that to me is quite interesting. You'd say, hey, no, and not returning is that as expected. Because by the time that I yield this, it's actually too much desperate. Set timeout function, and then you run that. But you run in this like synchronous system. It's like no. I would like to wait for that. Okay. No. Okay. It might be this particular console log. It's like, no, 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 no. Okay. Oh, unless I have to say something like this. And then I have to say something like this. Jill. I think this is pseudocode. I think this is pseudocode because even though the spy that is evaluating that is not somehow passing this control to that. You know what I mean? It's like not passing that control to that, bro. It's not passing that control to that. Let me see if you're actually calling that. Because I don't think that you're actually doing that. You know? Because it's like automatically okay, it's calling that. Oh, but it's working, bro. Okay, it is working. Okay, it is working. Just we are not. Oh, okay. It's because by the time that this function has been executed, all right, you might want to do something like this. Hey, let me pass. It's actually working. It's actually working. It's actually passing control over to this. All right. It's actually passing control over to this. It's passing control over to this and say console log. Now, the meaning of life is x plus g. And after 6 seconds, exactly, the meaning of life is 50. Well, we roundly calculated. Human errors, as usual. Is 40 exactly is this one. Damn, son. Damn, son. This is massive, bro. This is massive, bro. So anytime we are now doing is this, call and resume, pause and resume, and then you get the meaning of line 42. Holy shit. Oh my god. Oh, and I get it what's going on behind the scenes here with Jill, bro. Okay. Okay. Generators mimicking async behaviors, or generators with async behaviors a generators or simulate async await, exactly, simulate async await with generators and callbacks. This is huge, bro.
We still have an inversion of control issue. We've solved the non-local, non-sequential reasonability issue, but we have no solution currently in this code base for the inversion of control callback hell issue. So guess what we're going to do? We're going to put promises together with generators. Promises are going to solve our inversion of control issue, solve our trust issue, solve our flow control issue. Generators are going to solve our non-local, non-sequential reasonability issue. And the key recognition for this, instead of yielding an undefined value, we're going to wire this up so that we are going to yield a promise. Now I want you to think about this conceptually.
Exactly. This is async generators. Async generators. Async generators. Async generators. Simulate async await. Simulate async await with generators and callbacks.
Before I show you any code, look at me. Inside of my code, when I say yield and I make an AJAX call, if that AJAX call returns me a promise for it, am I yielding out its promise? Yes. So who's going to get the promise that I just yielded out? Whoever's driving my generator with its IT.next call, right? So imagine there's some plumbing somewhere, which is going to be in a framework or a library, but there's some plumbing somewhere that says IT.next, and what it gets back is a promise. So what's it going to do with that promise? It's going to say promise.then it.next. So here's how this works. We yield out a promise, pausing, and then we say .then, and when the promise resumes,
when the promise
resolves, we resume the generator. And then we yield and pause, and then and resume. And yield and pause, and resume.
We yield and pause and resume.
That's how we make that magic work. That's how we wire promises into the generator.
And we'll yield and pause.
We yield out promises, and then the promise, and then and resume. I mean, when the promise resolves, we resume the generator. And then we yield and pause.
And then we yield.
And then and resume. And yield and pause. And
yield and pause, and then it resume. But yield, pause, and pass control, and then it resume. Yield and pause and pass control, and then it resume. But this is it. Yield and pause and pass control, and then it resume. So this can be summarized in, so this flow control, this can be summarized in pause, pause, and pass control, and then resume. For the generators from the inside point of view, okay, from the inside perspective, is all about pause and pass control, pause and pass control, then resume, pause. Exactly. The generator from the inside perspective is all about pause on a yield keyword and pass control, then resume, pause and pass control, then resume, and so on until it finish or not. Okay. 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 And passing control back to the caller and resuming execution upon subsequent call. But this is the core of this, bro. This is the core of generators, my friend. This is the core of generator. From the inside perspective, is that pause until a G keyword, pause on a yield keyword, pass controls, freeze, wait for it to resume at some point in the future, and pass and pause, evaluate, pause, and pass control. Resume, pause, and pass control. Resume, pause, and pass control until it's finished or not. Okay. That'll be all for this video. That'll be all for this video, bro. That'll be all for this video, bro. You can say it's like, hey, H1. So what is the meaning? So what is the meaning? The meaning of life. Procreate, bro. Exactly. You say here, loading. Okay. Or thinking. thinking. Okay. You have a button. Tell me. Okay. And this button here will say, okay, show this thinking. Okay. So we're gonna run this on that, right? We can say, hey, define some variable here to say this is now the function to call meaning of life, which is this. Which is the helper function. Okay. Helper function to call the .next from the iterator, object, returning when calling a generator. Alright. Simulate future data the function simulate our async and await function with generator. Say on click. Okay, and then you say, all right, well, you are thinking. Okay. It's loading. So we can do something like this. It's just to have a deep understanding of this. Okay. Oh my God! Enough! Why, Jesus? Line 32. Okay. Okay. Alright, so you can say is this is loading here. Get element by ID and say loading. Okay, then you get ID and say loading here. So if loading is this, I want to now make this element visible. Okay, this is now low level details here. Document get element by ID loading. I want to show this element. Hidden. Okay, it has this property hidden. So hidden false. Alright, so by the time we click here, and then you're gonna get that. So if hidden now is false, show that to true, right? This is now HTML element attributes that we can have access to, and then you got it. And by the time they evaluate this is dumb, bro. Jesus fucking Christ. Okay. Loading element. Yeah, this is more like the HTML, that kind of thing. And the other is now for the text element. And then you do this. The text content, it'll be this. The meaning of line here is this config result and then result here. But this is quite powerful. This is quite powerful, bro. Loading function. So response, request, and response. Handling request and handling response here. Loading. Yeah, because this is the initial request and the response. Request logic. In this case, to actually show the content exactly. Loading and then response. Yeah, because this is a two private function here. Loading and response, man. Yeah, because this particular state will be shared across all of these functions, right? Loaded. Is loaded. Again, this is very specific to this stuff. So by the time that we call this particular function here, and then you gotta say respond here for this. But the core of this is that, bro. What we really care about is this logic here. Oh, and we need to pass this to log. Oh, okay. Okay. Yeah, make this happen here. Okay. Response, loading, and all that kind of stuff. There is passing control of that. That's interesting. And that'll be all for this video. Take care. Bye-bye.